Good afternoon and Jai Hind everyone. I Neeraj Sharma, Assistant Professor EC Department at AKGEC Engineering College, Ghaziabad. I am before here to present the video lecture for few complex topics for the subject antenna and wave propagation. So, as per our university scheme, which is provided by the university, so the code for this subject antenna and wave propagation, that is KEC 603. So here I am presenting the topic and chosen the topic coordinate systems from unit 1 of the given syllabus. So why I have chosen this topic? So before moving ahead, so because we are in as per the name suggests with this, for this subject, that is antenna and wave propagation. So in this antenna and wave propagation, so main component that we are using in present scenario, so this device antenna is already using as a number of applications. Either we are using a mobile phone, so in terms of mobile phone, for the different applications we are running on their mobile phone, we are all the applications using this antenna. For TV setup we are also using, for distance communication we are also using this antenna. So antenna is playing a very important role in the present scenario for the mode of communication. Either we are connecting in form of audio or in form of video as well as. Okay, so for that point of view we are using the main component, that is the antenna. Now this antenna, so for this antenna, before moving ahead, what it will done, so let's say I have just considered a figure from the book of Balanis, which will state that some source here, signal will be generated and it will now move to the some section. Okay, so this part is simply a source from here to here, that is a transmission line, and this portion, that is the antenna. So from antenna, like this type of radiation, free space this is free space wave. Okay, so here in consideration of our subject and the topic which I have chosen, so from this source we have any signal is source have generated any signal which is transmitting through this transmission line, and now this transmission line is connected to antenna, and the antenna will converting this V and I to in the form of E and H, which will named as an EM waves. Okay, so these EM waves are moving into the free space. Okay, so that means to just imagine or to analyze these free space waves, we are considering to analyze these EM waves, we are considering or we have the knowledge regarding the EM signals. So that means where they are locating, what is their position, what will be their amplitude. So for that point of view, to understand all these things in the detail analysis for these waves, we are discussing going with the first coordinate system. So I have chosen the topic coordinate system. So in the coordinate system, so the orthogonal, my topic is that orthogonal coordinate system and their transformation. So Orthogonal means just simply all coordinates are mutually orthogonal, means mutually perpendicular to each other. So they are the three coordinates for the wave. Three coordinates we have discussed or we have studied in this subject, like that means the rectangular coordinate system. The three coordinates are like rectangular coordinate system, cylindrical coordinate system, and the spherical coordinate system. So these three coordinate system that we have to study. Okay, in this subject KEC 603 antenna and wave propagation. Basically this subject will named is also antenna and wave propagation, but when we will go with the syllabus, that we will find the start unit 1 and unit 2, first two units for this subject basically belongs with the electromagnetic field theory, which is also a complete subject from in the previous syllabus. So where we will study all these things in details, but in summarized form we are studying only just to introductory part, we are studying only the 2 units for that subject, EM field. So EM field to study these waves. So as you can see in this previous picture, this free space diagram, free space waves that you are looking here. So this free space wave can be understood by its actual position where they are situated in in the space. So means we have to about its location we have to understood, or to just realize its pattern, how it will looks like when the antenna will radiate. So pattern will generate some pattern. So pattern is another thing here. So to just another pattern which will contain the EM waves. So understood this EM waves properly, we have to study this coordinate system, because it will have so many different shapes in form of pattern which is generated by an antenna. So in this way, for to understood these pattern properly, we are which is having some lines or curves from the combination of all these pattern is now generating. Now in this we are studying this coordinate system. So three coordinate system has been defined here, that is the rectangular coordinate system, cylindrical coordinate system, and the spherical coordinate system. So in this coordinate system, what will happen? So before starting, if let's say I am standing here any room, so just consider the room any corner of that room, let's say, and this will, if you consider any corner, so you can see at origin point either on the top or the bottom. Let's say we have considered the bottom part, so we are consider the bottom part, so we are looking at the three lines are moving, one is coming in this way, one is this way, and one toward the roof. Okay, so let's say these three are the coordinates. So means 3 dimensional we are discussing for any room. So in this we are considering the 3 lines. So if we are considering the 3 lines, so it will named as when we are discussing about only a line, means some straight path, or if we are considering without any curve. So we are considering, so this will system, when we are considering the 3 lines, so this system is known as the rectangular coordinate system or Cartesian coordinate system. Okay, so that means this coordinate system will have 3 lines which I discussed like in a room. Okay, so this will have a 3 lines or 0 curve. So mainly 3 dimensional view, 3 axes will be available there. So 3 lines if we are considering, that is a rectangular coordinate system. If we are considering along the line a angle, okay, curve, if we are considering any curve in this of any plane. So when we are considering the 2 lines and 1 curve, let's say line will be 2 lines and 1 curve. So if we are considering the 2 line and 1 curve, then this system will known as the cylindrical coordinate system. When if we are increasing the curve, okay, means curve will be 2 and line will be 1. So 1 line and 2 curve. One line and 2 curve. So it will named as an spherical coordinate system. So in this way we can understood the basic for these 3 different coordinate system. 3 lines means rectangular coordinate system. If 2 lines and 1 curve, that means cylindrical coordinate system. And if we are considering 1 line and 2 curve, that means it will be the spherical coordinate system. So now one by one we will discuss. So the first one coordinate system, that is the rectangular coordinate system or Cartesian coordinate system. Okay, so here you can see here point for the Cartesian coordinate we have discussed represented by the x, y, z with these 3 variables. Let's say I am just standing here. So any room's corner we are considering, x dimension is this one, this is x direction, this one is y direction, and above is the z direction towards the roof side. Okay, so that means here I am this, let's say this will be the center origin of our any corner of room. This one is the one direction x, this one is another direction y, and okay, and toward the roof, that is the, let's say, z direction. So any point is now located in the free space along these 3, let's say that is the x, y, z here point we are representing, and we are considering this system. So this is the example of Cartesian or rectangular coordinate system. Okay, so here we will discuss into the detail. So before going into the discussion, let's consider the picture which you have seen in the previous one. This is x axis, let's say it is y axis, that is the z axis. Any point P, x, comma, y, z will be here. So how we can represent its actual position, which can be explained with its amplitude as well as its direction. So that means if we will consider the vector in all the 3 direction, which will give its actual magnitude part as well as their direction. So here if I want to move here, if any point P is stated here, let's say, so how we can draw it? So just we have to move towards the x direction, let's say this one, let's say its amplitude will be ax, and when we have to give its direction, that means its amplitude will be multiplied by with its unit vector. So let's say ax is its unit vector in the direction of x. So we have to move in the x direction, then we have to move y. So y will be this direction, so we have to x move here, so we can move here up to y direction. Okay, so this will be ay, and its unit vector is ay. Then we have to move toward the z, so z will be this one top, so we can move here z, so its amplitude, let's say az, and its direction is az. So in this way, and its resultant, when we want to explain or represent its actual position at point P, so for that point of view we have to connect that point P xyz where it will reached, so we can join that point to the origin of that system, so we will get the resultant value. So here you can get the resultant value a here. Okay, resultant now we can get here. So in this way we can represent the vector of A in coordinate can be written here as AX, AY, AZ for this A, or you can write it like this: AX, AX plus AY, AY plus AZ, AZ. This one. Vector A value is AX, AX plus AY, AY plus AZ, AZ. That we can represent here in this way. So their directions, its ranges for the variables if we will consider. So we can consider the range will be given here by x range from minus infinite to plus infinite, y range from minus infinite to infinite, and z will be from minus infinite to plus infinite. So this will be the presentation for the rectangular or the Cartesian coordinate system. Next thing, if here for this different coordinate system, we have to represent the, we have to find out also their differential length, differential area and the differential volume. So for that point of view, to calculate the all these parameter like differential length, area and volume. So how we can find out for all the coordinate system? So for that point of view, we have to find out their length in all the directions, or means three directions: x, y, z, if we are discussing for another coordinate in that systems also. Okay, if we are cylindrical, so what the points will be there, so where we have to calculate the value of their length, as well as in the spherical. So here length calculation if I am doing, so for that point of view, what we are saying that, let's say I am drawing a figure here like this one: x, y, z. Okay, let's say any point P I have drawn here. Just a minute. Okay, so we can, let's say any point P is now located here somewhere. So in this we have to consider the direction. So in this x direction we have to consider the length, differential length means from the any length which is given to you, where some fractional part we are considering here. Let's say in the x direction we are considering the length dx, in the y direction whole length y we are considering a small length dy, and in the z direction we are considering the dz. Okay, these three are now we are considering. So when we plot these three in this, for this point, let's say if this area will created here, so this is the now if I will say, so this is direction, this will represented by dy parallel to this y axis, this one is parallel to this x axis, so it will be the dx, and this one direction is parallel to this one direction is parallel to this z axis, so it will, let's say, dz. So in this way we can calculate the value of differential length for in the all the direction. Now when we have to calculate the area, so for that point of view we are the area which is now looking here like this one. So this area, as we can see here, this one area, so this it will have the two it is creating in the yz plane, so it will have the z axis as well as the y axis. This one is z axis, this one is y axis. So area is d, just a minute, dy into dz. Okay, when we are looking from this side, direction is dx and the lengths are dx and dz, so area will be dx into dz, and when we are looking for here this one, so it will be y and the x, so it will dx into dy. And so in this way we can calculate the differential area in the different plane. So that means if I am looking here, if I am standing here any corner for this one, let's say it will be the room's corner, one direction is this, one is this, and one is this z. So when I am looking towards the, it means what? If I am here, that means just I am looking towards the wall which is in front of us, so that will be available into that plane where it will contain the z and y. So that plane will named as a yz plane. So that means in yz plane we will have the component of y direction and the z direction. So its actual normal direction will be into the x direction. Okay, so means if we have to calculate the area, actual area dy dz ax cap, so that which is now not we are considering, that will be the direction of that area. If I am considering this one, this part, this one part, x or z, that means it is we are now looking toward the xz plane or the side wall of our room. So that is the dxz plane, or we can say that here y will be 0. So we can name it as an xz plane or y is equal to 0 plane. So area will be dx into dz, which you can side. When I am looking, if we are considering this x direction, x dimension and the y dimension, that means z will be 0 here. That means in the roof, either we are discussing in the room which we are standing, the plane where we are standing, or the roof of that room. So it will be the xy plane of that room. So it will be the xy plane. So and the direction is in along the z direction. So the area will be dx into dz. And when we will calculate the value of volume, so volume will be the multiplication of all these three dimensions. The volume will be given by dv. Here length is given by dl, area ds, volume can be given by dv. So dv is equal to dx dy into dz. So this will be the volume of that sphere cube which is available into the coordinate system. So this will be the regarding the Cartesian coordinate system. Next one is the cylindrical coordinate system. So when I will discuss about the cylindrical coordinate system, that means we are considering the two lines and one curve. So this will follow the symmetry of any cylinder. So let's say in any room which I am situated or standing, just consider the corner, let's say in the xyz plane, like an xyz plane. So in xyz plane, let's say any cylinder we have to form, so we have to consider any radius, and let's say the radius will be a rho its value. Okay, so we will consider and we make a circle. From when we have to create the shape of any cylinder, what we have to go to take a consideration this rho as a radius, and when we will create a complete circle, and after creating circle from origin to ending point, then a circle will create. After that, when we will pick this circle point and pulled up towards the z direction. So in this way the structure formed that will named as a cylindrical system. It will figure the geometry we will get, it will like as a cylinder. Okay, so this will be the basic symmetry regarding the cylindrical coordinate system. So in this cylindrical coordinate system, xyz plane, as you can see here, so in this xyz plane, x direction dimension, y dimension, and this one is the z dimension. So let's say first what we are doing, we are from origin, we are considering a length. We are considering a length or radius, let's say rho we are considering, and we will make any circle, and we pick this circle and pulled up toward the z direction. So a surface will be in the z direction. So the point we are now getting here. So in this way we are making any cylinder. So the geometry will generate, it will act as a cylinder. So in this cylinder, cylindrical coordinate system point will be represented by rho, phi and z. Rho will be the displacement from the z axis. As you can see here, the point P, here this point P is rho, phi and z. Okay, so this rho, phi, z, so it will available here point. So its value rho will be angular radial displacement from z axis to the point in reference to this, making the lower part of that cylinder. So this will be the rho, phi, that is the angular displacement from the x axis, this one angular displacement, and z will be same as in the Cartesian coordinate system. So these are the point which we will take into the consideration in the cylindrical coordinate system. So these are the range of variables in this coordinate system, given by rho will be vary from 0 to infinite, means from origin to some any value. Phi will be to make a cylinder, it will from 0 to 2 pi, and z will be same as into the Cartesian. So it means a minus infinite to plus infinite. Okay. Now next one, after that point we are drawing its unit vector. So unit vector means in the direction where the components we are showing. So this will be the z component. So in this direction we are getting az unit vector. This one is rho, this one is rho. So in this direction we are getting the unit vector a rho, and this will be the, this will also create a part of this phi. So that means here in this direction we are getting the point a phi unit vector. So here a rho, a phi, a z will be the unit vector, and all are the mutually perpendicular to the each other. If we are doing the dot product, so for the same coordinate a rho dot a rho will be 1, a phi dot a phi will be 1. If we are multiplying the two different coordinate unit vector, that will become 0. Okay, so in this cylindrical coordinate system, we will, if we can see this one, the actual dimension of this coordinate system, as you can see cylindrical coordinate system x, y, z direction. So in reference to the or making a relation between rectangular or Cartesian coordinate system with the cylindrical coordinate system, we are now using this geometry. So this will x, y, z, this will be the rho, phi and z, rho, phi, z for the cylindrical coordinate system, x, y, z for the Cartesian coordinate system. So we want to make a relation between these two coordinate points. Okay, so for that point of view we are using this vector dimension diagram. So where when we are now plotting this one rho part which is making an angle phi, so when we will split it this portion into their tangential and the normal component. So after that when we will draw split into this tangential and the normal component, so this value will become, it is equal to parallel to this x, so it will x, its value equal to rho cos phi, and this value will be equal to the parallel to the y plane. So this is equal to y equal to rho sin phi, and z will be same way. If we want to calculate phi value, so just calculate rho value. So we can use trigonometry in this or in this one. So we can with the help of Pythagoras theorem we can now calculate the value of phi as well as the rho as well as the phi. So the values will be now in the given system cylindrical will be given by rho is x is equal to point transformation from cylindrical to Cartesian, x is equal to rho cos phi, y is equal to rho sin phi, z will be z, and from Cartesian to cylindrical, rho is equal to under root of x square plus y square, phi is equal to tan inverse y over x, z will be z. Okay, so this is a unit vector will be, it's a vector will be given by a rho, a phi, a z, or a is equal to a rho, small a rho, a phi, a z, a z. Okay, in the same way, what we have discussed in the differential length, volume, and the area, we can also calculate the differential length in the particular dimension. Let's say for the in the dimension of this rho, we have to consider the length, differential length d rho. In this direction we will consider the dz, and for this curvilinear shape we have to formula angle arc is equal to angle into radius, so rho into d phi. So in this direction the length will be radius value, arc value will be here rho into d phi. So similarly we can multiply in the same pattern what we did in Cartesian. We can calculate the value of volume, the area as well as the differential length we can calculate here. Okay. So this is cylindrical coordinate system. So this is the vector transformation from means ax, ay, az, is known to us. Then how we can calculate the a rho, a phi, az and a vice versa. So for that point of view, this will be the vector transformation, as you can see from a rho means from cylindrical to Cartesian, which will be given by this matrix ax, ay, az, cos phi minus sin phi 0, sin phi cos phi 0, 0, 0, 1. Same way we have to convert from Cartesian to cylindrical with the help of this matrix. We can convert the vector. So in this way we can convert the from cylinder to spherical, Cartesian to cylindrical, cylindrical to Cartesian. Okay, next one, last one, that is the spherical coordinate system. So in the spherical coordinate system we are considering the two curve and one length. So here the point will be given by r, theta and phi. So here this will be the radial displacement of from origin to the point P, that is r. Phi will be this angle and theta will be phi will be making from which we have created in the cylindrical from its x axis to angular movement from x axis to next side y side. Okay, same way from theta will be the movement from z axis to the y side. Okay, so in this way we can define the r, theta and phi. So the ranges of r will be 0 to infinite, theta from 0 to pi, phi will be 0 to 2 pi, same as in the cylindrical coordinate system. Their unit vectors are defined by in the direction r, a r, in the direction of phi, a phi, in the direction of a theta. So this will be the spherical coordinate system. So this is now from my side to for this basics of coordinate system, which will give the information regarding the coordinate system and the conversion from Cartesian to cylindrical, cylindrical to Cartesian point, as well as the vector transformation. So this is the reference I have chosen taken from the book Matthew and O. Sadiku. So thank you and Jai Hind.